Welcome to physics class, your tutor Black Adam. So we're solving a problem that we have bullet of mass 2 gram and then 1 kg block. So that's our block there. That is before the collision, and then it moves to the other side. So which is a wood block, which is at rest. So VI there is 0. So we have all those informations. Friction at 1.96 Newton. So that's our friction there. And then we have traveled 0.09 meter before stopping, so our final velocity is 0. So defining Newton's law in terms of motion, in terms of momentum, we'll say that force net acting on an object is equivalent to the rate of change of momentum. Okay, so how does it come to rate of change of momentum? Remember, force net is ma, so we have mass there, so acceleration means change in velocity over change in time. So if we take the numerators up there, so that is mass times velocity, it gives us momentum. So remember, that's change in velocity, so it's going to be change in momentum over change in time. So that is force net is equivalent to the rate of change of momentum of that object. So that's the best way. I prefer that than the longest one where it says that force net acting on an object is direct proportional to the acceleration of the object in direction of the force net and inverse proportional to the mass. That is a long statement actually. So this is my shorter, simpler, and more understood. And actually it says the best definition for Newton's second law. So let us come to the information that we're given. We're given mass 2 gram, distance 0.09, traveled by the wooden object. And then so we have mass of a bullet, there is 2 gram. So we convert the gram into SI units, so multiply by 1. So that's gonna be 1 kg over 1000 grams. So it means the same thing. 1 kg and 1000 gram means the same thing. So we're multiplying the number by 1 actually, not changing anything, but just changing the unit. So it's gonna be 2 divided by 1000 to give us 0.02 kg. So that's the mass of the bullet. And what else do we know? We also know that mass of the wood is 1 kg, so that's 1. And we know that we're using the symbol B for bullet and W for wood. Okay, so whenever you see a subscript of B, bullet, subscript of W, that means wood. And velocity of bullet initially we do not know, but we know that the final velocity of bullet after it went through the wood is 50 meters per second. And then the other information is friction. Now we'll get to that later. So we're going to use the conservation of linear momentum first. So for every collision that happens, we use conservation of linear momentum, even if we don't find the answer, but at least we'll have an expression of which we can use that later to come up with the actual point. And then later we have mass of bullet, velocity of bullet initial, plus mass of wood, velocity of wood initial. That collision, that's the collision, that's before collision. That will be after the collision, which is mass of bullet, velocity of bullet final, plus mass of wood, velocity of wood final. So that is during the collision. So we have that sorted out, and then from there we have to calculate substitute. So we're going to substitute all the information. Alright, so we substitute 0.002. We have velocity of bullet initial plus mass, there is 1 kg for the wood, and then we have initial speed, it was stationary as 0 to give us mass of bullet, which is 0.002, and then velocity of remember that's bullet after collision, that's 50 meter per second, plus mass of wood is 1, and velocity of wood final, which is unknown. Then from there we use velocity we saw for VBI. So VBI there will give us that information there. So 0.002 multiplied by 50 gives us 0.1. So I have 0.1, 1 times that is going to be VWF. So we have V velocity of wood final after collision, and divide by 0.002. So we have two unknowns. We have velocity of bullet initial unknown, and then we have velocity of wood final unknown. So we got to know the other information. Now, what we know that after the collision, we're only giving information of the wood. So we're gonna use the wood that it traveled 0.09 meter from there to there, and we also know that initially it was 0. But then final it was, initially we don't know, after the collision, then final there it was 0. Okay, so we're going to use equation of motions, which is velocity final is equals to velocity initial, velocity of final squared is equals to velocity initial squared plus 2 times acceleration times change in displacement. So we got to find acceleration. So coming to acceleration, what we have to do is we need to draw a free body diagram. So friction there. So horizontally we only have friction as our force net. So that is only force there acting is friction. So remember that we ignore the direction of air resistance and all that. So the only thing is friction there. And from there we draw free body, that's friction, normal force, weight. So that's weight, that's normal force, and that's friction. So you can see friction is the only force acting there. And then we have to use our equation. I think we have to use force net, Newton's second law. So force net is equivalent to MA, and our force net is friction, kinetic friction. So coming to kinetic friction, we have our mass is 1, so that's according to the wood. So that's free body for the wood, So for the wood, mass is 1 and acceleration. So friction there, we told that friction, let's come to friction. Friction kinetic is 1.96 that the wood is experiencing. So that is 1.96 newtons. So that is 1.96 newtons. So 1.96 is equivalent, so that's negative, is equivalent to acceleration. Why negative? Because it's moving on the other direction, opposite the direction of motion. So taking right as positive, left is going to be negative. And now we have to substitute the velocity final 0, velocity initial unknown, plus 2. Our acceleration is negative 1.96, and then our displacement is 0.09. Yeah, that's 0.09 meter. That's our displacement. So 0.09. Solving for VI. So you can see that okay, that's 0 there. And that is VI squared. So that's negative 2 times negative 1.96 times 0.09 gives us 0.35 0.3528. Now solving for VI is going to be positive or negative root of 0. Remember, you take 0.358 to the other side, so that's gonna be 0.3528, and again that will mean we have 0.59397. So rounding that to 2 decimal places, we have velocity of wood initial, that's gonna be 0.60. So we got to translate that So our final velocity now becomes our initial velocity. Remember, we have two processes: the one of the collision and then the one after the collision, when the object move against the friction. Okay, so yeah, so that is 0. That's 0.60 meter per second. Okay, now that's just my translation there, that you have vi there, which is also v final, on two different stages of which the block experienced, and then v would initiate after. Okay, so it's after collision. Yeah, so that's v would initial after collision. So that's how you need to interpret it. So it's like the final on the other side becomes the initial on the other side, on two different processes. We're looking at the velocity of the wood initially before it started to slide, on the surface, before it started to slide. And then what was it? It was also the final velocity after the collision. So that's how we equate it and how we interpret it based on the problem. Alright, so that'll be v final before sliding. Okay, before sliding. And now what we do, we go to the previous equation where we have vbi is equals to 0.1 plus, and then we have the vwf, so which is 0.60, all of that over 0.002. So you're gonna add 0.1 plus 0.60, find the answer there. I think it's gonna be 0.70. Then you divide that by 0.00 to give you 350 meter per second. So that's fair. Like, that's the normal speed of a bullet. So we have steps there that we need to consider. Step 1, 2, 3, and then step 4 we use kinematics equations. Step 5, 6, so that's 4, that's 5. Step 6, step 7, 8, interpretation, 9, 10, and 11. So that's 8, 9, 10, and 11. So any question, you just refer to the steps. Thank you for watching, and don't forget to subscribe or follow. Leave comments.